A microwave glow older than Earth is whispering a map tonight. That afterglow shows the hidden rules that built the cosmos. Invisible processes quietly steer cosmic evolution. By invisible processes, I mean forces and flows we infer, not see. They leave signatures while staying out of sight. You care because they decide where stars form and when galaxies grow. Gravity carves the paths that matter ends up following. Dark matter lays the scaffolds that normal gas falls into. Radiation pushes, magnetic fields thread gas, turbulence stirs the mix. Feedback from stars and black holes throttles the fuel supply. Dark matter outweighs atoms by 5-to-1 in plain terms. Net result, structure grows on a hidden stage that we can map. Tonight, meet the quiet engines steering everything we later notice. Starlight arcs around a giant cluster, forming a faint blue ring. That ring is gravity made visible, bent light telling a secret. Gravity is spacetime curving around mass and energy. It matters because curvature funnels matter, and matter deepens curvature. Tiny quantum jitters from the Big Bang became small density highs. Each high curved spacetime slightly, inviting nearby matter to fall. Falling matter deepened the curve, pulling even more. Radiation pressure slowed growth early on, then recombination let atoms fall freely. Halos grew by mergers and smooth flows, building a hierarchy over time. Clusters mark the deepest wells, linked by thin filaments between them. Einstein rings appear when source, lens, and observer line up precisely. Offsets break rings into arcs, and multiple mirrored images form. Measuring those shapes reveals the mass map, including unseen matter. Keplerian curves fail on galactic scales, rotation stays oddly flat. Gravity remains the driver, but unseen matter boosts the pull. One sentence recap: gravity is geometry that amplifies tiny beginnings. Pull back until galaxies look like beads on smoky threads. Those threads trace dark matter, the unseen mass shaping the web. Dark matter is matter that barely interacts except through gravity. You care because it sets the stage where gas can cool. It streams in early, forming halos from tiny seeds to giants. Halos merge violently, then relax into dense centers and long outskirts. Gas drifts into those wells, shocks, and radiates away heat. Colder gas sinks deeper, spinning into disks that birth stars. Filaments keep feeding galaxies, even after clusters form. The cosmic ratio is about 5 parts dark matter to 1 part baryons. Simulations like Illustris and Eagle reproduce these webs convincingly. One sentence recap: dark matter provides the scaffolding normal matter fills. Now zoom to a galaxy's heart, where a jet drills the halo. Feedback is energy returned to gas that regulates future growth. It matters because unchecked cooling would flood disks with stars. Massive stars explode, stirring and heating their birth clouds. Winds from young clusters blow cavities, starving dense pockets. Black holes accrete gas, then launch jets that carve bubbles. Those bubbles rise, mix, and spread heat through the halo. Radiation pressure kicks dust, which drags gas outward together. In clusters, cavities tens of kiloparsecs wide hot gas. Each bubble represents a duty cycle, reheating before cooling runaway. Only a few % of gas becomes stars as a rule of thumb. Without feedback, models overshoot the stellar mass significantly. One sentence recap: feedback is the thermostat galaxies secretly obey. Gas in star factories looks calm from afar, but it seethes. Turbulence is chaotic motion that shreds and compresses clouds. Magnetic fields are invisible lines that add tension and pressure. You care because these two set the clock for star birth. Supersonic eddies crash, forming filaments, while shocks raise densities. Gravity grabs the densest knots, starting collapse toward protostars. Magnetic tension resists collapse, redirecting flows along field lines. Ambipolar drift lets neutrals slip past ions, easing infall. Angular momentum sheds through magnetic braking and tiny outflows. Clouds show Mach numbers around 10 in real terms. Densities follow log-normal shapes with heavy tails from gravity. Stars form slowly, only about 1% per freefall time. Polarization maps reveal aligned dust, tracing field direction clearly. Zeeman splitting measurements show micro-Gauss strengths in cold gas. One sentence recap: turbulence and fields throttle collapse into stars. Out in the dark, background photons glow at 2.7. Entropy counts how many microstates fit one macrostate. You care because this counting gives time its direction. As space expands, radiation cools and temperature differences appear. Those differences are free energy, fuel for work and order. Gravity takes advantage by clumping matter, releasing heat to space. Local order grows in stars and planets, while entropy rises overall. The CMB sits near 2.725 Kelvin today. At recombination, it was around 3000 Kelvin, glowing orange. Black holes have entropy tied to area, and Hawking showed they have a tiny temperature. One sentence recap: order blossoms locally, while total entropy keeps rising. Inside stars, nuclei fuse, turning hydrogen into helium and heavier elements. Metallicity is the fraction of elements heavier than helium. You care because metals cool gas, build planets, and seed life. First stars formed with almost no metals, and they were massive and short-lived. They exploded, scattering carbon, oxygen, and iron into space. Later stars formed from enriched gas, making denser, cooler clouds. Disks around them gathered dust grains that stuck and grew into rocks. That process built planets, some with oceans and weather. The sun's metallicity is near 0.014. Stars with higher metallicity host giant planets about twice as often. One sentence recap: chemistry enriches the fuel that later builds worlds. Telescopes are biased eyes, and the universe knows it. Selection effects happen when our methods prefer certain things. You care because bias can fake trends or hide truths. Measure indirectly, and then model the bias to correct it. Gravitational lensing maps mass by distorting distant galaxy shapes. Shear is tiny, just a few percent in most fields. Average many images, and a mass map emerges cleanly. Redshift turns spectra into distances because light stretches with space. Type Ia supernovae serve as standard candles when selection is modeled. The CMB shows temperature ripples about 1 part in 100,000. Polarization patterns add lensing and reionization clues. Spectroscopy fingerprints elements, revealing enrichment and outflows. One sentence recap: we see the hidden by tracing its footprints. That ancient afterglow still whispers, and now you know why. The quiet engines behind it are not mystical, just hidden. Gravity, dark scaffolds, feedback, fields, entropy, and chemistry choreograph growth. They guide the show while light simply reports the outcome. Everything you see is the visible summary of invisible work. Net result: the universe feels less random and more legible. If you enjoyed this, tap subscribe for the next deep dive. Until then, look up and picture the currents beneath. Keep that picture handy when a headline screams surprise. Oftentimes, the engine was humming there all along.